Hello again. This is me, Dr. Ali El-Bahrawy. I am going to talk in this session on three important subjects related to spreadsheets. The first one has to do with pivot table. Pivot table is a function inside spreadsheet that allows you to handle tables efficiently. Not only that, to produce reports and produce graphs in a very simple way. And the word Nile here, because the example I'm going to show you has to do with the river Nile. This is a map of the river Nile. The Nile goes through 11 different countries, including Sudan, Democratic Republic of Congo, Ethiopia, Eritrea, Uganda, Burundi, Tanzania, South Sudan, Rwanda, Kenya, and Egypt. If you put some of the data related to water resources in a table, you create this simple database composed of records and fields. And for each field there is a field or a column title that tells you, for example, for each state, what is the amount of blue water or rivers in billion cubic per meter. The green water is the rainfall for rainfall agriculture. The total, which is a summation of the first two values. Dependency ratio, livestock in heads of animals, its consumption, the number of proctorates like wetlands and parks, and their water consumption. And the last three records has to do with groundwater divided between renewable and non-renewable resources, also expressed in units of billion cubic meter per year. To know how a pivot table works, you just put yourself inside any cell, highlight any cell, or like the cell B6 here, and then hit insert pivot table. When you do that, it knows exactly the limits of the table that shows the database, and if you hit OK, it will give you this screen that shows you all the column headings here and 4 different areas here. One for filters or pages. We are not going to use this now. One for columns, one for rows, and one for values. If I like to analyze the data in the table, for example, I like to show the total amount of water by summing the green water and the blue water for each country, I can take the state and drag it to rows and put the sum of total water in the values area. Here, because the default is count, you have to click this to tell the computer I want the sum. You get this table, and then you can click pivot chart, and then you get you click the column graph and you stick like clustered column, you get this thing. You said OK, then you get the graph here. Again, as I mentioned before, sometimes you don't like to plot the data as it appears in the table. For this particular example, we like to sort the data to give us an idea about the ranking of the total water resources in the Nile Basin countries. Therefore, you go to any place in this column and you click right click and then get sort and largest to simplest to smallest, and then you get this. You can also do a lot of things. For example, in the same 3 first columns of the database, you can add the sum of blue water to the sum of green water and put them in a stacked column diagram. This way, to show you how it works, I am going to make a demo. I will go to the table of data, put myself in any cell, insert pivot table, then OK. then I will take state here, and instead of using blue and green water, I use the livestock. I put the livestock here, but it counts the number of occurrence, but I have to change the count into sum to get the real numbers inside the cells. Then I click pivot chart, and I said okay. If I want columns or clustered columns, then I want to sort the data. I will sort it largest to smallest, and then I get this. Really interesting and beautiful. No? Tamam. I will go now to another subject, which is non-typical charts. As you've seen from my previous session, that in Excel there is some certain main types of charts and subtypes, and these are fixed. You cannot change them, you cannot add new ones, but you can use them to create things that are not there by combining some of the feature and using Excel options. And I'm going to give you 4 examples of such non-typical charts that you can create using Excel. The population pyramid, the rainfall runoff hydrographs, the timeline or Gantt chart, and clustered stacked columns. This shows a population pyramid of Egypt. Population pyramids give the number of males and females in age ranges of 5 years after birth up to more than 75 years old. Now you get the males on the right side, the number of females on the left side, and you get the age ranges here. How did I create this graph? You have to think. But to give you a tip, this is created using stacked bar chart. The other example has to do with rainfall runoff, where I was able to express the rainfall in millimeters per hour, put them on secondary y-axis, and use the flow in cubic meters per second, put them on the primary y-axis, and draw the rain in clustered column or column graph, and plot the flow hydrograph using a line graph. You can see here, which is typical of storms, that the peak of the rain is not the same as the peak of the flood, and there is some attenuation here. This is of course something related to water resources. A timeline, which is my third example, is atypical of what you get when you study project management, where it shows the activities of the project, the duration of each activity, where the timeline is expressed in weeks, and these are the names of the activities. If you study project management, you know that activities can be critical or non-critical. Critical means if it is delayed by, say, 1 week, the completion time will be delayed by 1 week. But non-critical activities, we have some range to move here, where if we move this activity to the right up till here, nothing will happen and the project will end at its ending time. You can see that the critical activities are number 10, number 40, number 70, and number 90. The rest are non-critical activities. The last example of non-typical graph is cluster stacked column. Excel can plot either stacked or clustered, but to plot cluster stacked column graph, you have to arrange data in a certain way, and you have to highlight the ranges for x and y axis in a way to get this. To explain this graph, it shows how much rain and how much water released from the IS1 dam according to different scenarios, and the corresponding groundwater and reuse of drainage water by using a simulation model. And the x-axis corresponds to released water from the high dam expressed in this is 50.5 billion cubic meter per year, this is 55.5, and this is 61.1, to study different scenarios. The third point here is common mistakes. There are too many mistakes actually, but these are the most 3 common mistakes before getting to the next session of looking carefully on some published graphs that has a lot of points to discuss with you. But these 3 common mistakes are primary and secondary axis, date and axis, line versus scatter. I call them that, but to explain them, I get into this example here, where we have a table of data showing the flow in the eastern, middle, and western delta expressed in billion cubic meter per year, and the salinity expressed in gram per cubic meters. You notice here that there are big orders of magnitude between the numbers here and the numbers here. If you plot them together using the same y-axis, this is what you get. You cannot read the flow in billion cubic meter because of we are using only one y-axis. To solve this problem, you have to plot this column and this column in 2 different y-axes this way. This way you can read the salinity on the right y-axis, and you can read the flow in the left axis. Therefore, you can see that this is the actual relation between the 3 points that are not explained here because of the automatic scaling using the 2 columns with the same y-axis. The second point is the date. In Excel there is date arithmetic and there is time arithmetic, where dates and time are entered in a certain format. If you don't watch this format, computer will look at the dates as if they are labels, and if you draw like that, you get this curve here. Again, dates are like numbers. Look at them. If the difference between the dates are not the same, you cannot use a line graph. You have to use an XY scatter, or tell the computer that these are dates by entering the data using the date arithmetic format, and this way you get this graph here. Now, if you do that and the computer recognizes that the x-axis is dates, he will do automatic scaling, and he will not produce these dates as was produced here by spelling them or showing all of them. They will appear here according to the relative value located in the exact position denoted by this automatic scaling of the date. The last point on common mistakes is the line versus scatter. We talked in the previous session about the difference between a line graph and an XY scatter graph. Here is an example of misuse of graph type. This is a cross section in a canal or a channel where you plot the level against the distance. If you don't notice what you are doing and you used a line graph, you will get a cross section. Looks like a cross section, but again, this is line graph Y because the numbers appear on the x-axis between the tick marks and the marker is in the middle. But this does not show the relative distances between these numbers, because here the distance between 10 and 12 is the same as the distance between 12 and 52. To correct this, you change the chart type and make it XY scatter, and this is what you get. You will get automatic scaling here. These points, these values will not appear on the x-axis, and the points here will show in their relative exact position. After this, after covering these 3 important points on spreadsheets, again I will give you a musical break, and this time you are going to listen to Mr. Johann Strauss II. He is Austrian also, but he is very famous with writing waltz. What you are going to listen to is the Blue Danube, very famous. It will take only 2 minutes. Enjoy the information and enjoy the music.